Hey, good morning, everybody. Thank you for joining us here at Webinar Wednesdays with Wales Darby. My name is Anthony Tosi, and we will be presenting the SpacePak air-to-water heat pump. It's, I don't know what to say, it's new, but it's definitely newer to a lot. To my left, I guess would be my left, would be Rick Koester. He's also will be presenting with today. Again, thank you for all being here. If you have any issues with some of your audio in your drop down, you have your little go-to menu there. Sometimes just toggling in the audio between different devices, whether it be the desktop or maybe a Bluetooth or whatever. I think the choices are there. Sometimes that helps straighten out your audio if you're trying to listen in. Yeah, phone, no audio, or computer audio. Those are the three options I see anyway. We've done presentations before with SpacePak, and you know, with this product line, it does hold a lot of where maybe the current modern day heating and cooling needs to go. So, you know, it's a little bit of I don't want to be the first to try it maybe moments. You know, the fear of God gets into people. We don't believe in what we're really set out to do, and that is provide BTUs. Right. You have to remember that if we make BTUs, that's comfort, right? It's not always about, well, I need a higher temperature. No, what we do with those temperatures and our ratings is that we deliver BTUs, right? So this new air to water versus air source heat pumps has a lot of options, maybe over air. And we'd like to show, if you had not seen this opportunity, what we're doing. You know, besides some local mandates or changing of local law 97, something like that. We have some mandates that are in place here and other parts of the country. This stuff is pretty popular. So, you know, if you are aware of air to water, and you know, it's old hat, I'd love to hear some conversations and share. But you know, for maybe, hey, I'm just hearing about this, I need to get involved because my business approach needs to change. You know, consumers are educating themselves, and we need to be able to answer and feel confident in giving answers. So I just did a presentation. It's kind of odd that we got involved with an electrical organization. So Nassau County, Suffolk County here on Long Island, they have, you know, organizations, all electricians, and I've done presentations, and it was really kind of scratching the surface like with Keiko controls. And then I brought something very much different this year with, hey, these are heat pumps and, you know, air to water, and getting them a little bit more exposed to what they might be asked to hardwire, you know, wire up in people's homes. Right. So it was a good round table discussion, and actually I'm getting utilities now wanting me to be part of their kind of round tables because they're going to start offering more rebates for the air side, air to water side versus just air side. So change of, you know, the winds are changing. So be prepared. Thank you for being here. Yep. There are some handouts for you as well in your drop down. It says handouts there, 4 of 5. So just make yourself aware and grab them as you go. You know, little door prizes for all. Yeah. All right. So
we loaded it up with the Takeout residential catalog in there. So that's kind of, we're going to talk briefly about some pipe sizing. So we'll give you some tips on that guy. I always like the solutions form, where we call it the tips and tricks, right? So that's everything from not just, I think a lot of people today might have known SpacePak as a high velocity product, you know, high velocity air, but now we're having these conversations with air to water. Most people, just an awareness of the product offering from SpacePak on the hydronic side has been awesome. So a lot of those little tips are inside those our solutions guide there. I did put out brand new residential line sheet in there, so that's all in there without contacts. And I think we threw a little bonus, the design form. Right? So we'll talk about that at the end. One of the services that SpacePak offers as well, as far as putting a system together and helping out with the design, they do a big portion of it for us. So it's always a good resource. So let's see what we got next.
You know, the name SpacePak is something that's been around for a long time. The small duct high velocity, right? This photo here is showing you typical application where maybe we were always in the attic with, you know, some small ducts doing some high velocity air distribution, would be DX. They always had hydro coils, but it was never like, you know, for heating maybe off a boiler, or chillers really weren't in the wheelhouse back then for the most part, not that I was aware of anyway. They did step into chillers, and I'm going to go probably a dozen years at this point. And I did recall, man, it was such a foreign thing. You're doing what, you know, like this thing is outside the house and producing really cold or really hot water. So it's an application based. We have to be very understanding when we are discussing the heating side that we're talking about 120-degree water. You know, the parts and pieces of a hydronic system doesn't really change in respect to pumping and piping and zoning, right? Distribution, what we need to do for the houses, zones and all. But it's just the source now is what we're changing up. High efficiencies through a good majority of our heating season, perhaps, depending on where you live in the United States. You know, the further north you go, obviously you have colder climates. But where we're sitting right here on Long Island, or maybe a little bit west, not to say too far west, or elevation starts to take place. You know, we're closer to the ocean, keeps us warm. So for a lot of applications here on the island, and being radiant, right? So hydronic based, first of all, and then we have radiant. So there is already a beautiful match of low temperature source to now our emitter being the floor. So, you know, you need to see those opportunities, and then therefore, you know, if your customer is asking for something, you know, again, they're doing their research, they're doing their due diligence, and you know, we can have resources and solutions for them. Kind of cool.
Yeah, we've been having fun. The conversations we've had in the last couple of weeks, it seems like, you know, we would get maybe one every 2 weeks, get a phone call on something hydronics with, you know, an air and water heat pump. Now it seems like almost every day there's a conversation, a phone call, something, you know, coming in, especially now. Getting a little exciting as rebates start to come into our area, so we're hoping that kind of kicks in. That drives a lot of this stuff here. So in the chat, if you guys don't mind, you know, we try to keep this, you know, as interactive as we can. We love the conversation. So these slides that we're going to kind of see as we go through this are really there as a reference and to start conversation. And we want to be as interactive with you guys there. So Anthony's got the chat in front of him. If you don't mind, you know, where you watching from today, and you know, have you been involved with air to water heat pumps before? Have you installed them, you know, in your region? So, you know, we're going to kind of go through this, have a conversation of, you know, what an application looks like, give you some tips, maybe some install stuff there, but there will be a lot of application pictures and then design layouts and stuff like that. So as we kind of go through here, you know, just remember this house, you know, this is pretty cool. I always love this on our pop-ups and stuff like that, kind of showing you entire systems. And you know, having a lot of the conversations I've had have been with plumbers, you know, who have not even got into heat pumps at all. So instead of having to learn a whole new trade, basically, you know, we can kind of fit the heat pump now into what they do every day, the pumping and piping aspect of it. So the layout of the home, you know, there's many different options is what this layout is showing you. This might not be every home, but there is a good mix of, you know, what we can do as far as, like Anthony was just saying, radiant heating, the high velocity. You know, a combination of the two of them works really nice. And then maybe some rooms you got these high walls, and it's always cool to see all the different things we can do. And I think that's, you know, you're doing next week low temperature water heating, right, or hydronics, right? So I think that's where most people have a hard time grasping that we can actually heat homes with 100-something degrees of water.
Absolutely.
We got some people coming in. We got upstate New York. Water too.
There you go. Thank you, Russ.
Cool. Love to see where you guys are coming from and watching and stuff like that. We seem to be spreading out pretty good lately. So got a good group with us today, some familiar faces. I could let you look at that stuff as we kind of go through. Okay. So, you know, the heat pump solution and why, right? So when we talk about, you know, some of the things that are going on now, you know, going back, you know, not just, you know, heating homes with water and stuff like that. You know, I always say, you know, when's the last time water changed? Look at the refrigerant stuff we're going to start going through, you know. R32 being in the space. There is no, with air to water, you have no physical refrigerant in the space. So that's a huge one right there that gets us in a lot of different applications. Even as a plumber coming into the world of heat pumps, there's no refrigeration license needed because it's a self-contained system. There is one, the lower one on the slide here, that's a split system. So you do need to work with refrigerant, but our two monoblock systems I should say, yeah, SIMs and ILHPs. You know, there's no refrigerant for you to touch or adjust when you're out there in the field, which is pretty cool. And then definitely, yeah, a better humidity control. There's a lot of different things, you know, as far as piping and pumping, which we're going to get into in the next couple of minutes here, so it makes this a little bit easier. But water makes sense in a lot of ways, right? We're not limited to how many zones, right? It's really, you know, how big, you know, is your, you know, your creativity really there? How many zones do you want? You know, it's not going to affect the system. You know, when we get into micro loads, we're going to talk about the buffer tank and all of that. There's some cool things we could do there. You know, just this physical size of a pipe, you know, to carry the BTUs going through it compared to a duct, right? So the physical space, the homes that I know we've been working in lately, it seems there's less and less room to run piping and duct work and all these other provisions. You know, what's your term?
What?
Architectural relief.
Oh, yes.
We don't see that anymore. So, you know, now we'll, you know, I worked with I think it was an architect and a GC, you know, reviewing a SpacePak project, and it was just so funny, even with the high velocity that we do and getting our ducts in small spots. The first words out of the architect and all these design people were, you have no mechanical rooms and there's no soffits. You know, and these are some of the challenges I think we're going to see, where why water now, you know, you can run a pipe, a 1-inch pipe or a 3/4 pipe or something like that, sliding PEX. It just makes sense. You know, being able to integrate, you know, with an existing hydronic system, you know, and that's kind of what we're going to cover next week, you know, talking about, you know, the output of, you know, baseboard, understanding, you know, load calculations are huge when we start talking about these, you know, high efficiency pieces of equipment. You know, we got to match BTUs if we have the water temp we need and we're getting the output of the, whatever that terminal unit is. And why can't we heat it? So
Absolutely.
a lot of fun stuff there. And we're not restricted. I like that one too. Not restricted in length and lift of line set. You know, it's really down to your skills of sizing a pipe, which we're going to look at in a few seconds here as we go forward. So again, that's what this kind of slide was there for as a reference. You know, we hear a lot of the times homeowners don't want to see the outdoor unit, you know, and I think with the refrigerant-based systems, you're kind of restricted to how far you can go away from the home, you know, with your line sets, where with water, it's just a matter of being able to size a pump. You know, you want it to go an extra 100 feet away, we need a bigger pump, you know, and that's really it. Circular.
Yeah, the pumping and piping aspect's been around us for, you know, 100 some odd years. And like Rick was saying, fluid, water, it doesn't ever change. I mean, yeah, there might be some instances where we need some glycol, but again, it's pumping and piping. So the basis of what we know about universal hydronics formula, you know, there's practices that we should all have as a baseline in the world of comfort using water, you know. Refrigerant and air, you know, there are some deficiencies in distance and sizing and whatever we need to do for that delivery of comfort. Not knocking it at all, but man, we have options where you kind of know when you have a leak right away. You know, like there's some other benefits. There should be, you know, some downtime for repairs, weighing in or charging a system, understanding the process of refrigerant versus water. There's a lot of, you know, differences. So I have to say, with the current, not only is a knock, but the current talent pool, you know, this is repeatable, it's understandable, it's not so, you know, scientific.
Right.
So.
Right. Yeah, no, it's gonna get challenging. So just on the screen, we kind of have some of the components that make up the system, you know, and it's not too complicated, right? So right now we're kind of talking about, you know, the outdoor unit, or I guess you could call it, I like to label it as the outdoor system, you know, almost, where you got to look at this as two different, and I got a slide coming up that's going to break down the indoor and outdoor piping. But if you look at the components, a lot of them we're pretty much familiar with on the inside, you know, besides the heat pump itself, which, you know, we really don't have to interact with too much. It's hooking up two pipes and hooking up a wire, control wire, right? There's not much you got to do with the outdoor unit. But looking at the piping options we do offer from outdoors, we were just talking about distances, and you know, I think that's the challenge sometimes, is how far can we go? Are we okay with sizing the circulator? We've seen some crazy stuff. I've had guys put circulators outside, just had that recently. But yeah, it's just really, you know, understanding our piping and being creative and all that fun stuff. So we got that going on. Obviously a circulator to move that water around, and we will be using a combination of a water and glycol mix. So you're not much. Where we are, we're probably about 15%, 15, 20%. I see some colder regions. Where we have a Colorado in there and a North Dakota.
I was looking, yeah.
Yeah, we got some people
Yep, Colorado.
out there, right? So it gets pretty
Elevation.
cold out there. So your percentages might be a little bit different, right? But in our region, you know, we have some considerations there too when we start moving chilled water versus hot water, and then now you have 15-20% glycol. You know, been on jobs we cracked a valve, purge valve, and gotten bright blue water, I think 100% concentrate. Lose a lot of BTUs, you got to pump harder, all of that fun stuff. So we need to understand that. So
Heat transfer too is also given up.
Correct, right.
BTU delivery.
Yep. So we're gonna have. It's funny you said that. We're gonna have a chart coming up that kind of shows some of the capacity losses, and then maybe having an upsize circulator as we go on. But so this slide kind of just gives you that breakdown of what a piping a system and what that's gonna look like. And I like to treat it as two different systems, right? Because that buffer tank's gonna isolate it, right? It hydraulically separates the flows. But here's my outdoor circuit. Right, so I'm worried about, I got some piping, an outdoor unit, a buffer tank, and a circulator. And then the rest are kind of accessories that we would recommend, strainers, maybe magnet separator, who knows, then with on the other side of that tank. But there's some things you definitely would want to have on there, isolation. We've got to talk about insulation as well. It's always, heating wise might not be a big deal to you, but chilled water now, we're moving 47-degree water in the summer with 80% humidity out there, that pipe's going to be sweating like crazy. So insulation is key. You can never have too much on a chilled water system. You want to get everything though, valves. I had a guy the other day who had that Zoom call with, he's building a house out of Montauk to do high velocity in the air to water. And he was saying with his insulation in his home, even with his knowledge of what can happen with a chilled system, he went around and took all the handles off his ball valves, and then made sure that wasn't going to rust up. So
Sure.
We've seen that before too. You don't get insulation and those metal handles will start sweating. So, some things that, definitely talk about when we got the piping side of it, and insulating and sizing and all that fun stuff. And then we got what you want to call maybe the system side, the side of the system where, now that can be high velocity like we've traditionally done. We got a house we did recently with a contractor, 2 of these systems. I think their design temp was about 5 degrees where they were. And they're running on, I think it's 120 degrees of water, maybe just shy of that, and they're heating their home just fine, which is awesome to see, So, and that could be anything on the other side. It doesn't have to be the high velocity air handler. It could be gradient,
Sure.
like we spoke about. It could really be anything you want as long as it has some kind of output at a low water temp.
Absolutely.
And it's pretty cool to see a lot of the manufacturers, and we've seen ours where they're switching their charts over now. In the past, they were always,
Higher water temperatures.
higher 180, all of that.
Showing no lower outputs for, water temperatures lower than 140, 160 maybe.
Right.
So, the thought about what we've been doing hydronically and heating, and then switch that over to having that one appliance to do both heating and cooling. There are other piping layouts to maybe do dual tanks and isolation, so it's amazing to see we have a hot tank and a cold tank. That 120 is really where we want to kind of understand the envelope of the building. If it doesn't require more BTUs and we keep beating it up with 180 or higher degree water, why? It's a waste. So we have more efficiency, and even though it's electric, anything right now we're talking it's 100% with just straight on electric. Now we're talking refrigerant based, inverter stuff. So this DC processing and now really boosting what our BTUs are for a kilowatt of energy, that's where you're going to see some big outputs, for dollars, energy dollars.
Yeah, I see a lot of questions coming in, so that's cool. So we'll interact with you guys there, kind of answer some of them. I saw, I think that was Seth asking if we distribute, nationwide. We don't distribute anything technically, Seth. We're a manufacturer's rep for SpacePak in the New York metro area, New Jersey. We probably should have started with that early on, so I'm glad you asked that question. So Anthony and I are out of our New York office, and then we have John, Jim, and Rob as far as what we do in the training side and technical support, design aspects. A lot of other, departments within Wales Darby. What are we, about 70 strong now, as far as employees go? But we represent, and all SpacePak product comes out of our distribution partners around us. So good touch back on that. So yeah, so I think, having those conversations with low water temp, and like I was saying, that one job, and here it is, it's just a little layout of it, and kind of looking at it, the creativity here was, just we want a redundancy, number one, right? So having that backup there with a gas boiler, when you have those conversations, the way they're pushing everything, their heat pumps, and everybody's putting, we're Fujitsu reps, so we're seeing it a lot, right? So you put in Fujitsu systems in, you don't really have much flexibility down the road. Everything's refrigerant based there as a system, where with, I guess, air to water systems and hydronic systems, you can have that kind of flexibility to work with a gas or an oil system, so not having to necessarily rip everything out like you might have to do on a refrigerant side. Here we can kind of work without fossil fuels. I think we see some great opportunities doing that now where people have boilers, they're just kind of getting pressure to go electric. There's some of these boilers, if we had a conversation a couple months ago, a contractor reached out to me to help with a design, and he went and did a load calculation and kind of figured that in order to do the entire home, he needed 2 of the outdoor units, which obviously could drive the cost of the job off, pretty high. And, the homeowner wasn't going to go for 2, so we kind of walked away from the job. And, we had a discussion afterwards, and I asked him, like, what did you have in the home already, And he was like, it was a pure oil-fired boiler, it was like 10 years old. And man, that thing has like 20 years of life expectancy, cast iron oil, it was a good boiler. And I asked him, I said, why not just put the air to water in and let's see how much of a heating season we can do if we look at the load calculation. Maybe we do 3/4 of the winter on the heat pump, and then when we really hit those cold days, it'll switch over automatically to the boiler to help it out, And, he went back, and, I got to reach back out to him and see, how he made out. But, he went back and offered that, and I believe he got that job, so he was able to recover it. But we don't necessarily have to rip everything out every time we talk about, air to water. We can integrate with these systems, and that's kind of what we did. I think this one was built from scratch when we first did it, but we wanted that redundancy to propane, boiler. This way, if there was something going on with an outdoor unit, we have the redundancy of a second unit, so they kind of work together there. But we also had the boiler if we needed it to, and then we let the boiler take care of our domestic load, right? So, we have some options, and I might have a slide or two. So if you see it, I'll bring it back up again if I see it. Yeah, I thought I had another. It might be coming up. But with the domestic, we have some options there where maybe we use the heat pumps to preheat, an electric water heater, and then we boost that temperature up, maybe a 20-degree rise, 30 degrees the most, so kind of getting the efficiencies of the heat pump, and then the water heater very rarely has to, do anything hard. It's just kind of boosting it up a little bit. So in this case, like I said, we had the high velocity air handlers. There were 2 of them. I think we're pushing around 120 degrees of water, I want to say. It might be a little less by the time it hits that air handler, maybe 117 or so. But we've been heating the home perfectly there. And then they wanted to keep the garage tempered a little bit too, so we do it through an air, the Modine Lodronic, which is a low temperature, air handler unit. So that was a lot of fun. We got the home heating done, the garage, the indirect load. So we kind of covered everything here. So this was a fun project.
Kid in a candy store building it.
Yeah, it really is, And then even to go back and to your point, like we were able to do this as Wales Darby, and I think this is what entices a lot of people. We're not just providing an outdoor unit, as far as Wales Darby is concerned, right? SpacePak might offer, you might not have high velocity air handlers in the home. It might be other options. It doesn't have to be SpacePak,
Sure.
But the whole project itself, when we're taking care of it, is all Wales Darby. So if you have issues with other products along the line there, we can help you in all those aspects. So, that was a big thing for this contractor, was being able to put the system together and then support him throughout the whole thing. It wasn't go find your own control,
right?
Go have them size the circulators for you. I didn't have to work with anybody else, which made the design side, and then even him putting everything together very, very easy. So that was a lot of fun.
Yeah, we definitely do design package approach versus equipment sales, or
Correct.
Just being a part of the system. We want to control, or not say control, but we want to have the understanding of all of the system, because you should call us, and it's one phone call, easy convenience.
Yeah.
If you go back a slide really quick, and I know we might be discussing this, but here you see the introduction to a dual fuel, right? The boiler there, and you say 120, man, I just don't feel comfortable. Well, you look at our heating season and what
actually will be covered with 120-degree water very efficiently versus turning on a boiler or something else to just have it sit there and sit idle with 180-degree or plus water. You know, we can really do a good bit of the 70 to 80, maybe 90% of the heating season. At least I know my territory because of what I've been doing with low ambient or low temperatures.
Right.
So, and only then turn on something, and maybe it's for domestic even, or maybe it's for that really, you know, a few days or cold nights where it's dipping into single digits. So, you know, it's just application based, and that's where we can help you with understanding maybe what your requirements really are. It's a comfort level too. If you just don't understand how to do a heat loss and really know, man, I think I need more BTUs, or that 120 scares me. Well, those are two different separate conversations, I guess.
Yeah.
So.
No, absolutely. And that's why the load calculation is so important, you know, being able to see and know what you can do and all of that stuff, you know.
I've done a presentation where, you know, it's just about that low temperature side, and just getting people comfortable and say, well, you know, we understand low temperature is good for radiant, so why don't we think it's good for anywhere else?
Right.
You know, and that's that little switch in your head. It's like, yeah, absolutely, we do it there, but why not somewhere else?
Pushing 98-degree water or something like that, you know.
People are comfortable.
Exactly. You know, going back to the heating season, it was funny. I was looking at that with the bin data, they call it, you know, based on, I think it was like last year or the year before, you know, and I think it's like 5,400 heating hours in our territory where we are, you know, and it was like 78 hours, you know, it was less than 10 degrees, you know, so less than 10 degrees, 78 hours. I mean, you're talking an hour here overnight, an hour there, you know, that's not a lot in the wintertime, you know, so that's not. Got some stuff coming in, so it's good to see. A lot of you guys have had some experience with air to water. That's cool. Some manufacturers I have not even heard of before. I see that one. That's cool, Jeff.
Yeah, Jeff over there with solar.
Yep. Yeah, so there's a lot of cool stuff that we have options, you know, for, you know, so kind of integrate with whatever you currently have or build from scratch. You know, we're seeing different styles of buffer tanks. You know, we represent two, which have been really good, and we're going to look at them in a few minutes. You know, but looking at one of the newer units that was released, this is probably the first release, you know, getting into the inverter side, you know, with the heat pumps. You know, we've seen that, you know, obviously in the refrigerant side with Fujitsu, but, you know, now having SpacePak into the inverter side, these things have been really cool. You know, there's some little things there. I don't want to go too deep in with this training, but, you know, maybe with the inverter technology, it gives us a, you know, I guess the opportunity to go with a smaller buffer tank than what we've had in the past, you know, where now we're able to invert down and kind of match those smaller loads, so we don't really need as big of a buffer tank, which is cool. So, you know, that's a whole other conversation. But, you know, this unit, you know, when you think about what we've heard in the past from, you know, mini splits and stuff like that, I mean, listening to this condenser, and I know it's almost identical, but to imagine that this is even quieter than some of the mini split condensers that are out there in the market today. I think that was a really cool selling feature there, you know, for homeowners not wanting to hear or see something like this on the side of the home, not being able to hear it's very important. So definitely has some low ambient capabilities there. You know, just really cool stuff with this machine. 5-year parts, 10-year compressor. You know, so you are now certified, you know, list or as far as contractors go, it came through our training, so we can get you on there too. We do want to, and I know Anthony and I, we've talked about this, we want to try and get maybe a certification going on the island out of our Wales Darby office. So, you know, if you have interest in that, please throw that in the chat, kind of give us an idea.
Yeah, MacArthur Airport's 10 minutes away. You can Uber right in. Fly in, Uber.
I like that. Jimmy tried to pick it up.
Yeah, right. We'll have lunch.
Yeah, that'll be good. So again, just kind of looking at that basic layout. So what we're concerned with, or really what that outdoor unit is concerned with, is just satisfying the temperature that we designated that buffer tank, right? So, you know, we pick the temperature, usually by a sensor through our control, our SSIC control. We'll see in a few minutes. That's going to monitor that buffer tank, making sure if we do need temperature, whether it's heating or cooling. And that was another kind of thing that I haven't gotten into application yet. I'm excited to try one, but, you know, being able to, you know, small buildings, small multifamily, right? You talk about having to use heating and cooling at the same time, where, you know, I've had a couple projects where they've wanted to kind of monitor so they can bill a tenant, let's say, you know, and now we're doing air to water, we're making a central system, you know. how do you meter that? And there's some products out there as far as BTU metering that you can do, but you can also now have maybe a heated tank and a chilled water tank.
Right.
You know, now you talk about like with a VRF system, if you wanted to be able to get multiple indoor units in the mini split world, one in heating, one in cooling, you had to have them on 2 systems or wait, you know, to figure out which one you wanted. Where air to water, we have that flexibility as well, where if you're good with piping and you understand it, for addition of 3-way valves and stuff like that, we can have a heated tank and a chilled water tank. So we could technically give you simultaneously, you know, maybe we're putting some heat into the floor as tempering, but we got a dehumidification system going, you know, when we were, you know, running cooling. You know, we could do that at the same time because the outdoor unit's going to see which one was crying first, which tank needs that temperature back. It's going to let it heat it or chill it down. And then once it's satisfied, it goes over to the other tank. So the control strategy itself and the outdoor unit just kind of work together and just make sure that that buffer tank is always satisfied, whether it's multiple tanks. You know, we've had those conversations before where it may be cheaper to buy storage of BTUs than it is to make the BTUs. So, you know, there's different considerations there. I think I got a couple of cool pictures of where people took advantage of the storage side, over maybe what they were producing. But yeah, this is just that basic layout.
Just really quickly, maybe you even covered here about power. What do we need? So you can see here, John, I'm sorry, you were asking about power. So you can see 230 single phase.
Yeah.
So those are for the SMI 36 and the 60. And I don't think it really changes for any of the other equipment.
Yeah,
So
they're all 230, and this has popped up a couple
it's
times.
residential,
especially
remember. So single phase is where we want to be.
Single phase, but what happens is, like New York City, I've had these conversations a lot, you know, if we're installing this in our city, the city's only providing, or Con Ed, I should say, only provides 208, right? So this is a 230 volt system. So it will not be friendly. It may work. You might have some board issues, stuff like that. So we got to supply the proper voltage. That's a good point, you know, what kind of power. If you don't have 230 volts, then you will need to get a transformer, you know, and that's something that we've had guys do. So we can look at that as far as the design. That's one of the questions we would ask.
Right.
Anything you want to share before we kind of move forward? I see a lot of questions coming in, or conversation.
Well, just some of the, you know, they were asking, maybe someone from Philly would come join us. I told them to stay tuned for maybe more details with the certification class.
Cool.
Wi-Fi was one of the things about the controller. If someone wants to know if we have Wi-Fi capability, and I know they are working on a new release or a module add-on. I forget, we were discussing with another install. I had a local with Mike down in Nassau County.
Yeah.
Man came to our certification class. He was on board and did it for his own house, made himself a believer.
Yep.
And now he can go out to his customers. So he had a nice project first time. So we had a couple of little setbacks, and job site visit was always nice to go and touch it and see it. So discussions were about Wi-Fi there as well.
Yeah, that's a big thing. You know, it's one of those things, and we have the conversations all the time about Wi-Fi and how many people want it, and everybody wants it, but then nobody uses it. You know, so that's a tough conversation. But yeah, there could be some stuff coming down the pipeline. So looking here, we're just looking at the specs on the 2 systems in that sim model, the 36 3-ton and the 5-ton. You know, obviously we just talked about the electrical capacity. So but what we look for now is obviously with size of pipes, you know, to push the BTUs, you know, back into that buffer tank and vice versa. You know, so we do have a rated water flow that has to go through the machine. So we want, when we do size that circulator, we want to be for the SIM 36, that's going to be 7 GPM and just over 12 GPM for 5-ton. So that could change, you know, now that with throwing glycol in the mix and stuff like that. You'll see the next important one there is going to be your water pressure drop. So that's the pressure drop through the outdoor unit, which is quite high on some systems, right? So we got 6 feet on, or 6 PSI. So we got to convert that with size in a circulator, which that TACO catalog has that in there. You know, how do we figure out, you know, what is the pressure drop or the head that, you know, I need to design around, as well as the GPM. Because we give you PSI, we're going to take the PSI and multiply that by 2.31. That's going to tell us in feet of head what that is. So obviously it's going to be about 23 feet, you know, for the SIM 60. That is if we used 100% water. So we just got to keep that in mind as well. If we're putting glycol in the system, which we do have to have at least a little bit, depending on your region, even if you're in a warmer, region, it's beneficial to have just slight, concentrations down there. Not so much for outdoor piping, but there is a possibility you're moving water through a refrigerant heat exchanger, you could freeze inside there. So that's the purpose of having that extra glycol, or just having a little bit in there. So having a pressure drop is one of the things we need when sizing that circulator. And then the required GPM, depending on the outdoor unit you're using. Depending on the piping we're using, whether we're using copper or PEX. This is a chart that comes out of our install manual, so you can see, what is that pressure, and this is in feet of head. So we're looking at that there. So if you had you can see the differences, and let's see if this laser pointer actually works. So I'll check that out.
Ooh, fancy.
Moving up. All right. So if we had to flow the 12, or we'll go with the 10 that SIM had to do, right? 10 GPM. You can see here we have a pressure drop of 13.4 if we use 1-inch piping. Now, can I use 1-inch piping? Yeah, of course I can. Now I got a larger circulator because the resistance is going to be a lot higher. Excuse me. So if I bumped it up to 1.25 inch pipe, a little bit harder to work with, maybe a little bit on cost, but to move that same 10 GPM, the pressure drop's only 5 feet ahead compared to 13. That's a pretty considerable drop right there, and maybe a big drop in price for that circulator you might have to use to pump that water through there. And then even drop it from PEX to copper. So depending on your distance, if it's feasible to do copper all the way, we go from 5.2 1.25 inch PEX to 2.6. So
Just if I may, there's a couple of questions about temperature rise and asking 7 GPM and 12 GPM. I guess you had it on the chart before, or is that?
The GPM through the unit.
Yeah.
Yeah, 10 and I'm sorry. Yeah, it was 12, a little over 12 and 7. Yep.
So we're asking about temperature rise, I guess, and thinking this is a closed system. So
Yeah.
return water from your system if we're max at 120, I
Depends
guess.
on the circulator too. What size and how we move the water through. But yeah, it's typically, I want to say it was 10 to 20 degree delta that we're designing off of. I want to say it's a good question. I know we had the conversations, just not top of my head right now.
Right.
What that number was. Yeah, it's going to be a rise, but that's going to be based on your circulator and your delta T, so, and that could be a design aspect too, but there is a low temperature that we want to, provide back to the unit, safe minimum and stuff like that, which we would talk about in one of our certifications.
Yeah.
So the other side of that, obviously, talking about it and adding up those numbers and then coming up with a final number, that would be for 100% water, like we said. And then we got to come to this chart, and you can see the top is ethylene glycol. We're going to see the lower one, propylene glycol. If we were doing 10%, we look at a pressure drop increase. So we'll do whatever that pressure drop we calculated was, and multiply that by 1.10, and that's going to be your final number for 10%. And as we go up, you can see that number gets larger. And on the other side of that is the capacity. And I might even have, let's see, I did do that. So 30%, you would multiply by 1.34. So glycol wise, we also got to take into consideration the number above it. I thought I highlighted it. I guess I did not. 0.96 would be my capacity multiplier. So once I do my load and I kind of figure out what the machine's going to do on my design day and see if I cover my load, I might be close there. But remember, if you don't multiply that total number, the capacity of what you're getting out of that terminal, or you think you're getting out of that terminal unit at a given outdoor temperature and water temp, we got to multiply that number by 0.96, and that's going to actually tell us how many BTUs we get out of the system. So the more glycol we put in, the bigger capacity drop. Right? Anything to say to that?
No, you could.
Good, beautiful. So obviously, 2 bits of information we're going to need is going to be the GPM we got to move, and what is the total resistance we have to overcome for that circulator. So once we get that information, we can come in here. This is the take-off full line catalog you got in your handout section, so don't forget to download that. We'll come into this back section here, and we can kind of look at some of these pump curves and figure out which circulator makes sense. And sometimes I've had these conversations just with somebody recent. We're trying to keep the cost down, and any repair issues. We don't want to Sometimes it might be the circulator you see on the screen, that could be a $1,500 circulator for all we know. But if that something were to happen, what is that lead time to get a replacement?
Sure.
Am I down now? All of that stuff comes into play, and that's what we talk about. I'd love to sell you that more expensive pump, but I think it might be better in some cases. We just did this with a guy, 2 0011s, right? So we doubled our head. We did it in series, 8 to 10 inches between, circulator to circulator. You don't want to bolt the flanges together. But we did that, and now, yeah, if the 0011 goes down, it's a lot easier to find a 0011 than it might be to find a VR circulator, So, there's some design, considerations there, but, this book is a huge tool for us now, what were we, 2-3 years, probably even a little bit more since Takeo came out with this.
The book?
Yeah,
it's like the 3rd revision because I keep adding new stuff. So
time's gone by, but
we're now involved with some kind of contractor rewards. So that's a
Right.
new page in there and so forth. So new products in there. 0018 is key, for some neat stuff.
yeah, seeing those curves, it gives us a better understanding of what we can and cannot do. But, that's the nice thing, working with Wales Darby, we have, we got the best when it comes to PEX, Lupinar, we got the Takeo, we have all those little key components to put that system together. So sizing it just makes things so much easier.
Quick question here. What is the temperature we will see at minimum heating capacity? So I think the temperature is what you set it for, right? And I think if our emitters are sized, for something less than 120, 120 is our threshold. I don't know if we're going to get much more if it really changes because it's warmer out.
Right.
We are struggling with obviously refrigerant-based compression and turning that into heat energy. So I think 120 would be our top, and then you can obviously lower that if you choose to go to maybe an application for a lower temp gradient or whatever you choose.
Yeah, and I thought I had a reference here to that question. I forget what the outdoor temperature was, but you can see, I don't know, is this an AHRI thing? Is this at 47 degrees or something? I got to look at it again. Might be a 47-degree outdoor temp with, I think it's 120 degrees of water or something like that, or 120 degrees return is the way they say it. This tells us what the minimum BTUs would be, what we would drive down to, right? So,
Right.
And again, the
Like a turn down ratio almost.
Yes, and those numbers are going to change. That's why I wanted to go back here. Is we give you BTUs, the water temp I think is your discretion, and then whatever the design was, and then you're going to get an X amount of BTUs coming out of there. So too many variables really to state one number.
I know we have some good people on the website, and I was looking up this morning about AHRI 550590. That's actually what air to water heat pumps are being tested at. So I just wanted to confirm. I know the air source stuff and what the parameters are there, and it doesn't seem to be reality for most of my applications. So I make people aware.
Yeah.
You're reading specifications or outputs, but what was the test parameters really set at? So it's kind of an eye opener when you hear some of those numbers.
Yeah.
So for the air to water, I got to do a little more research. So if someone has that information, want to share it, that'd be awesome. What are the test parameters for air to water heat pumps for heating and for cooling?
Right. And
Outdoor versus indoor.
There is a standard that they do follow. But this is a chart you would get, based on a terminal unit. This is an example of our high velocity air handler. So depending on, and again, this becomes sizing a circulator, understanding what we can do. Not just putting it in because this will be the one that'll do everything. We want to know, or we want to use that circulator as a tool and let it work for us, right? So depending on the air handler, I'm not stuck with 1 GPM. If you look at the charts, the left and the right here, we'll do the pressure drop after this. We'll do the capacities. So you can kind of see, and see if I can point out, we got our cooling capacities here and our heating here. So based on our GPM that we're flowing to these air handlers, you can see we give you an entering water temp, right? So this is entering the actual air handler would be 120 degree, 140 degree, or a little bit higher, right? So based on whatever you were putting into it, those are your BTU values. You can see cooling here, so that's chilled water, right? So a couple different charts here. So these are pretty cool because they don't lie, right? They're going to tell you if I flow 7 GPM and at this, water temp, I'm getting X amount of BTUs, right? So I think this is where we kind of introduce some maybe components we're not familiar with, like circuit setters, and stuff like that, where we can really dial in how many GPM we're doing. We're dialing into BTUs. I had a project where we had some air handlers, and it just wasn't something that was put into design. We're using one circulator to do and I want to say it was the VT circulator, the Delta T. And we had 2 air handlers, so when the zone valves opened, water could have went down to the least resistance, right? The one right next to us in a mechanical room instead of the one up in the attic. So the GPMs were off, but we didn't know what they were. And we knew we were getting this complaint where just on a really cold days, we weren't getting the performance out of the system. We knew when we looked at the load calculation, the desired water temp we wanted to use, how many BTUs we should be able to get. Just we weren't getting it, so we ended up putting some circuit setters on there. I got some samples for that project, and we were able to dial into GPM. We were able to adjust the one downstairs to what it needed to be, and we had an increase in GPM now to the air handler up in the attic, and now we were getting the BTUs that we designed around. So since then, no complaints on the coldest days of the year. So that was pretty cool, and being able to understand that these charts are going to help us really understand, there is no more just throw it in, it's a 3-ton, it's 400, whatever, a ton per 400 square feet. There are no rule of thumbs when designing these systems anymore. We need to see a load calculation. We got to have that manual J, and then we can look at our emitters and see if we're getting, based on the water temps we want, are we getting the BTUs to deliver, right? It's not so much the water temp like we're going to discuss next week, it's BTU delivery. So these charts will help you out. There you go. I should have did that the first time. Let's just click one more. But that's a little exploded view, so you can see those 3 water temps for heating. And again, this air handler is not just for air to water heat pumps, right? So we need to know where we play. We're going to be looking at that bottom line when we talk about air to water heat pumps. Maybe if I have a boiler involved, it's a dual fuel, and that boiler is boosting the temperature from there up to these higher water temps. We could do that and get more BTU output out of it. And it's a huge jump. You can see anywhere from 50 all the way up to maybe 67,000 BTUs, BTUs, all the way up to just about 85,000 BTUs, right? So that's the one air handler, the 3.5 ton system, but based on the water temp and the GPM, we can increase those BTUs, getting out into the space. So I think that's what's pretty cool about the air and water stuff is we have that flexibility. You're not just stuck and married to the source and the emitter. We can kind of play around with water temps, GPM, and all this other stuff and tailor, the BTUs we need to get to that space. If I had a problem where I was over delivering, what do I could put a small circulator in, just deliver less GPM, and it's going to drop my output, right? Refrigerant, you put that system in, and there is no modifications and tweaks to get less output and all of that other stuff, right? There might be some band-aids, but there's nothing really in the design side where we have that flexibility. So water, again, I love, I think it wins out over refrigerant all day just for that aspect.
Just to mention the use of PEX. PEX on the OD is identical to copper, but the ID is smaller. So to say like for like and size for size, I've had some applications on the domestic side. So I'm just mentioning, we're talking about flow here and delivery, and if you're a guy who swapped copper out for PEX and thinking it's like for like, just be aware your flow characteristics does change. The ID is smaller.
Yeah.
An introduction of glycol, then it adds another different factor.
Exactly.
So I don't know if those charts were earlier for copper or PEX, but
yeah,
just know there are differences.
Yeah, that's a big thing. Make sure it's oxygen barrier too. Closed loop system, right? We don't want oxygen getting in there. So as we kind of talk about buffer tanks, I'm going to go back a little right here. So, just we're not going to get deep into this, but this is kind of how we size buffer tanks. I thought we don't have anything to take on one, but we do have it in a solution sort of tips and tricks and the handouts. There is a little guide in here. But we're just kind of looking at about for every 7.5 gallons of system volume. You're talking, that's, or I should say, you need 7.5 gallons of volume per ton, right, of the unit's capacity. So whatever that lowest turn down is, and that's where the inverter comes in and why we can go with a smaller tank. And they're using an example here where minimum turn down is 20,000 BTUs. That would put us right in the market for that 13-gallon buffer tank, which was something I don't think we've had, right? That was an introduction really when the inverters came out. It was
fairly new introduction, yeah.
Yeah. So buffer tanks, again, just think of it as a battery, right? There's not too much to it. It looks like a regular water heater, electric water heater, but a couple different configurations. As you saw in some of the diagrams, everything that we had there was all 4-pipe, we call it, right? So 2 pipes from the outdoor unit, 2 pipes out from the indoor system, so whatever's hooked up to that. So we offer this in 4 different sizes, the 13, 26, 40, and 80. Everything but the 13 has dual elements in it. So the 13-gallon has 1 3 kW element in it, where our larger systems, they come with dual. So those elements would be used, again, as a boost feature. We need to bump that temperature up a little bit. We're going to throw some quick BTUs. If you did the math, Anthony, I'll put you on the spot, the 2 3 kW, so 6 kW. How much heat are we getting out of that?
About 20,000 plus 22,000.
So over 20,000 BTUs. So
Yeah.
it's a good little dump. Yeah, if you're losing that on the heat pump side, maybe because of outdoor temp or the glycol, maybe that's my boost, right? So
What do you say, 6?
yeah, 6 kW.
20,500, call it, 478.
Oh, perfect.
Yeah.
Keep it there.
1 kW is 3413, so you do the math, 6 times 3413, you come up with 20,478.
So this was our offering through SpacePak, obviously. So this is something for, to keep that system a certain way. SpacePak, all the way throughout. We do offer, there's another manufacturer we represent, which is pretty cool, FlexCon. You guys might have heard of them once or twice. They've been around for a while. So we represent them on the expansion tank side, domestically and hydronically, as well as having this RNC buffer tank, which is pretty cool. It's a composite material inside. It's super light. Giving you a couple different options there, anywhere from 22 gallons, so still being able to get down for those smaller inverter systems, all the way up to 120. So we had this, I mentioned it earlier, it's always, sometimes it's cheaper to pay for the storage of the BTUs, and kind of feed off of that tank all day long or all night long, than go with a second outdoor unit. So we got to look at the system design there and the volume and all that stuff, but that's an option. I think I do have a slide, I think, later on as we wrap up, kind of go through some applications and projects that are out there. They went with that storage unit. They had, what was that, 900 gallons of storage in a basement or something like that. So we need that thing and maintain it and, just utilize it overnight. It doesn't produce any power overnight. Everything's stored throughout the day, which is cool. So field wiring for you guys out there, you got your line voltage coming in, so you have 230 volts. And then as far as controlling the system, we need a feed. These are dry contacts. They're going to be a 2-wire to the remote on-off terminals, and then the heat cool. So we want to know when that outdoor unit needs to come on, and we want to know what mode do I need to be in, heating or cool, right? So those are the 2 connections we do have. You'll notice, even on the power supply side, when we are saying we want 230 volts, so right, that's 2 legs and a ground. We also want a neutral sent out there as well, as you can see here. If I highlight that in the middle there. We want the neutral coming out, so a 4-wire, that's got to be communicated to your electrician. And we do that so that we can power the circulator for this outdoor unit off of the outdoor unit, right? So we need to have that neutral out there for the circulator. And then we have some auxiliary outputs, which we get into deeper in the certification training, and that's where we can maybe control, for domestic, stuff like that. So. Yeah, it's my reversing valve and my circulator. Cool. Got to add references. It does come with a touchscreen display. It is a controller, so technically it does not need to be on the system for it to operate, right? We can monitor some things there, program some stuff within the unit. It does not need to be there to operate. So we give you a 65-foot conductor. It's a 5-wire shielded wire. So if you needed to extend it, we could go up to 600 feet away. So you think, again, putting that thing remote in the woods or something like that and be able to get it back into the house. Now we can mount that controller in a mechanical room or something like that. So here's a quick little look at that. See some set points, temperatures, what's coming into the machine, what's going out, is it in cooling, heating. So it's very nice, very easy to navigate. Go through some error history, maybe some control stuff, how some of the relays are working in the auxiliary. So very easy to work with. I had a lot of fun with that thing. So being a heat pump, we always talk about clearances. So whether it's air to water or refrigerant, they all, they're important for us. We talk about heat exchanges. We talk about heat transfer. Right? If I don't have the air flow around the unit, then how do I collect the energy that, or reject the energy there?
That's it.
So clearances are key. I know in some places there might be some challenges, or maybe it was clear when you did the install, but now the homeowner comes back and puts a wall in front of it and puts all their bushes and trees and all of that stuff. There could be a drop in performance, and that might be why. So also being heat pumps, right? We talk about defrost. There's going to be a cycle. There's going to be condensate around that outdoor unit. So we want to make sure that thing's up off the ground and we're not trapping any refrigerant or any water in there, and having a refreeze or something like that. So follow the installation manual. You'll find a lot more of these dimensions. Get some look at some of the sims and some good applications. That one's on the ground because I believe it is covered. So pretty cool stuff there. Go back. It was,
It was an alcove, if I remember.
Is that what it was?
I
Yeah, I'm
think it
trying
was.
to remember the full picture, and I think I cut it off, obviously, but cropped it down a little bit. So then we get into the SIS. So everything I just talked about, in the beginning was all monoblock system, right? Where refrigerant's all contained inside the system. This is a little different. This is a two-part system. You got your outdoor unit, then you got your indoor unit. That indoor unit kind of looks like a wall-hung boiler. That's going to house our refrigerant to water heat exchanger. So in this case, we do need a refrigerant license because we are going to be running a line set from the indoor to the outdoor, right? So what this does is this kind of limits how much glycol I really do need in the system because I don't have piping outdoors. But now I still have to have that glycol in there, so I'm not freezing inside that indoor heat exchanger. So that's the purpose of having that there. So good capabilities there for anywhere from 21,000 BTUs to 71,000 BTUs in heating. Again, when do I get 71,000? We got to get to those design charts.
HRI.
Yeah, HRI. Yeah. So we got to see, what do we pump into this thing? What is the delta T? So size of the circulator, all that fun stuff. Again, we want to know what that performance is going to be coming out of there. So, and that is a low ambient heat pump down to minus 20 degrees, which is pretty cool, being able to take energy out of the air at minus 20.
I will say this with other manufacturers that we work pretty well with. If you go back a slide, that minus 20 is operational. So meaning it doesn't necessarily mean we're going to get 21,000 BTUs out of this unit at minus 20. So that's where where we find information charts are key, right? So if my load is something, and I'm thinking I have 21,000 BTUs in the bank at minus 20, you might be a little bit surprised. Maybe the house is not keeping up on the design day of whatever, minus 5, let's say.
Yeah.
So just got to find those charts and show us where the BTUs drop off. If we want to get into about the incentives, I mean, this is something that's typical.
Yeah, I'm seeing a question.
We're finding further north, air to water is in the programs, but right now where we are, they are just going to introduce it for 2024. They are, willing and understanding. They kind of have associations with the northern utilities with their programs. So we keep asking, as we know, in relationships with these people, where's the air to water? You guys do geothermal, and now why don't we do air source to water heat pumps?
Yeah, it's an education.
Yeah.
It's an education from what we've seen. There, like Anthony said, there is some rebates coming, hopefully sooner than later. The problem was, nobody, in our utility, our local utility, nobody's aware of it, and they don't understand it. And, they talk about efficiencies and why they want these things pushed out and they're electric and all of that. And we have geothermal leads, right? Which, yeah, you're getting good numbers for them, but we're even more efficient. So we should be getting the same dollars that you're going to have. And there's no field, there's no pump, there's no, you don't have to deal with any of that stuff. So just a lot better thing out there, but the incentives are there. We can't really speak to lead time. We don't run them and administer any of those programs, we know the availability and we try to get as much information as we can, but you would have to check their websites and stuff like that.
Yeah, we obviously are trying to do as much as we can with demand. Supply and demand is always the way they're going to stock their shelves.
Yeah.
So,
Oh, is
typically.
he talking lead time of the units?
Yeah, I believe so.
I thought he meant the incentives. Okay, that's a different thing. Okay, so that's pretty cool. Yeah, so lead time for us, I mean, what's nice is where we are in our territory, and again, where we're speaking to our region and what we represent. We've got them in Massachusetts, not too far away, and just south of us, down in North Carolina, so there's a couple different areas where these things come from where, lead times really aren't there. They build a lot of their controls in-house, which is really cool. So you're not dealing with, things shipped in, they're building a lot of their stuff. So when it does, if you have a problem, they usually want it back because they have the ability to test it and improve on it if there was a legitimate issue.
Right.
So lead times for us, it depends to, I think, where you were going with distribution.
These aren't made to order, so they are stocking them, and I think we do have some local distribution where they have a DC, not on the island where we are, but just on the other side, maybe Connecticut. So they do seem to have a stockable inventory, especially with the air to water.
Yeah.
So, check with your distributor, make them aware.
Right.
I would say you're looking, if you want to give someone a quote or something, if you're looking 4 to 6 weeks, just to be on the safe side, but this isn't made to order inventory.
Yeah, right. And like you said, the more awareness, the more we keep doing this stuff, doing air to water, and then it's increasing. The conversations every day used to be 100% refrigerant, get some hydronic coils here and there, maybe some Modine or A.O. Smith's, stuff. But lately, it's every email or phone call has had some kind of relation to air to water. So obviously, the awareness is there. The more we see it, the more we see it in the territory, the more the distributors, our partners, are going to be stocking it. So it really becomes, to your point, the demand. So there was that kind of layout there, very similar to what we had before, right? So going from the sim monoblock, running water pipes into the buffer tank. Here, we're running our water pipes from that indoor unit to the buffer tank. So it's just another addition to it. So, the benefits here for the increased cost and the additional parts and pieces is really more flexibility, be able to get, maybe a little bit larger home, right? So BTU output is going to be the difference maker there. Again, this is just another layout here utilizing maybe a fossil fuel, right? So we have the same SIS outdoor unit, indoor unit that I just showed, and then we have the addition here of a boiler, right? So very easy to integrate. The control strategy we have is awesome. So being able to, kind of work with both the boiler, we can do that a couple different ways. We can do it, maybe the buffer tank's just not keeping up, so we have a differential set point. If it gets to that lower range on the buffer tank, it'll now kick the boiler in and ask for help, right? We also have the ability to, based on outdoor temperature, where we want to hand it off to the boiler, and now the boiler is the one that maintains the temperature of the buffer tank. So again, you got to look at the piece of equipment you're putting in, see what your electrical rates are, COPs, we have charts for that as well to kind of get an idea on how many, how efficient this machine is at those lower temps. So maybe it does reach, maybe this is not an application for every single job, or this machine won't work for every single one, but once we figure out, where this thing's going to perform best, we do have the ability to handshake it off to something else, so we could have multiple stages, in different sources, And here's just another picture of that with the buffer tank there. This is pretty cool. This is being pretty creative. It looks like a lot of small little micro zones, So again, depending on what you want to pay for, you want to go with a larger battery or buffer tank. Some of those zones that are kicking off there, there's a good chance that outdoor unit never ever comes on because we satisfied the small load and barely took any temperature from the tank or the battery.
Right.
And do you want to comment on here?
I'm just noticing that halfway point on the lower, looks like there's two separate, maybe like we call it primary secondaries. I don't even know.
Yeah.
So it's interesting to see, like maybe we're just taking care of low temp on this job and maybe something else, I don't know, around the corner. I don't know.
It might just be all low temp.
It might be all low temp, right? Envelope over equipment is something we've heard, like, people are building these, very well insulated homes and thereby reducing energy dollars and they're, maintaining comfort levels. So, it's interesting to see how the building side of our structures are really driving our BTU loads down. So now low temperature is right in our wheelhouse again.
Yep.
So don't dismiss because, we've always been, let's say even for baseboard, a high temp. Well, we can show you a piece of baseboard that's a low temp emitter and puts out a lot of BTUs. So, room by room loads are good. You build out from there, you build your zones, and then you go to maybe the whole house and what can we carry the load with, and maybe there's a balance point. Maybe, okay, like I said, electrical, compression, heating and cooling gets us, I don't know, maybe 25 degrees outside. And when it dips below there, maybe we need a boost. Or maybe then once it gets 5 degrees outside, maybe we go full on fossil fuel or electric or something like that to get us the 180 or higher temperatures required.
Right.
So storage is key. If we can have something maintaining a good battery, as the reference is, for volume, right? And we can go as small as we need just to satisfy the outdoor chiller or heat pump, but if you had more storage, then it takes longer to draw that temperature down, and we use less energy to maintain.
Yeah.
Or longer run times, maybe.
Right.
Not short cycle.
Yeah, I left this one in here, just because, this project was a beta, obviously, as you see at the top there, but it was in Vermont, right? So if we're able to provide heating, low temp heating, right up in Vermont, right? You look at where we are, Long Island, it can be done. So I kind of threw that in there. This was just a quick look at the SSIC control. So this is something, the SpacePak interface control. So it does come with an outdoor sensor, a water temp sensor for the buffer tank. So that is provided. And then we're going to kind of, this is what's going to take information like, if you look at the diagram, we have landing spots here for our heating and cooling coming back from whatever zones are hooked up to the system, right? So depending on which one of these gets energized first, that's going to tell the outdoor unit whether it needs to be heating or cooling, right? So we have a lot of different, things going on here, some additions coming down the road. Obviously, maybe having an addition of a second buffer tank is something we've asked for. So definitely some cool stuff coming, and then very easy to work with. So I like that. This kind of just gets into, and I know Anthony's going to, kill this next week, man. There's going to be a big conversation.
28th.
Water temp, 28th.
Yeah,
I got a little. I think I got something at the end here.
Okay.
Those who don't know, we're doing it. But this is always brings up good conversation of what we can do and where is our sweet spot. So if we're talking that 120-degree range, which is that line right down the middle here, or to the left here, all these different applications between the radiant, different types of radiant applications, panel radiators are in the conversation, high velocity. We have those high wall, thin wall units, like I was just saying. So it brings in, a lot of these different conversations, and then you see traditional baseboard all the way up there in that 160 and above thing. Well, there's some baseboard manufacturers now that do have, low output ratings. So if we look at those charts, that line's actually going to continue down further now to those lower 110s, so 120s, 130s. So tons of options, and it's really up to you. Here's a couple of those radiant applications, whether it's a joist track setup that we do underneath, we might need a little boost there in some applications, depending on the insulation. Again, radiant, everything's about insulation, making sure the envelope's sealed. And then here's another application. Obviously, we're getting into some of the terminal units as we go forward here. This was the thin wall, right? So the thin wall itself in a small little footprint, call it 34 inches wide, very similar to a mini split head. We can potentially replace a lot of baseboard on this as well, even in a high temp application, doesn't always have to be, these don't have to be on the air to water system. They could be on anything, any type of hydronic system. So you get some good BTU numbers, as this chart shows, from 120 to 160, right? So 3 different models, 3 different outputs. So pay attention to that. Definitely a cool option. This one we just put on our Takeo display. We put together a hydronic display utilizing an electric boiler, and we threw the thin wall on there. So we're doing low temperature heating with it. It's got a nice little ECM driven motor. Nice connection points for your water lines, glass front, which is pretty cool. It looks really nice residentially. Nice little touch screen on it. So again, looking at the charts and understanding what my performance is going to be, at 120 degrees, you can see, entering water temp, I can get anywhere from 4,600 BTUs on the lowest model all the way up to just over 17,000 BTUs. That might be a big unit. It's almost 5 feet wide. But the BTUs I'm getting out of one thing on a wall, I don't have baseboard going all the way around, number one. But you look at load calcs, and I think that was, getting into high efficiency equipment like we do, we represent, and understanding load calculations and, making sure that we're following them. You get an understanding of what rooms really need, and then you get a bigger understanding of how many rooms we oversize, So entering or taking maybe a high temp application, and if it's capable, right, now introduce an air to water option at lowered water temps, you could be increasing the comfort in the home just by lowering the water temp, which sounds crazy, but comfort's not always cold. It could be, we're discomfortable. We could be really hot or really cold. So, questions?
Yeah, we're doing pretty good here, actually. Just working with
one about clearance, there's a photo of the wall, the unit hanging on the wall on the outside. So, the truth is, it's not a mandate that it has to be elevated. It just makes smart practice because it's an air source, air to water heat pump. So yeah, where do you live and what is your snow loads? What is potential for, covering that lower fan or whatever. So I've seen people not practice this good practice, and then they put it on a pad again. And then, I hope they have a snow removal company on the side. So when they get a no heat call, they got to go out there and make sure the unit gets some free air. So yes, 20 inches sounds good. I know I always tell people 24, potentially we can get 2 feet of snow here on Long Island. So if you're further north, it could be 3 feet, it can get a little ridiculous. Yeah.
Floor bracket, I should say.
Sure.
Right.
But off the ground is best for even like dehumidification, defrost maybe, or again, getting above any snow load.
Right.
Where we are, we have floods. So also it's not just snow, it's the water-based issues. So getting them off the ground is also a need.
Absolutely.
Yeah.
Before I get off this slide, this is what I was saying, replacing baseboard. We did some math here, at 120 degrees output or whatever it was. You do the math, we're replacing 19 feet of baseboard with that UT 196. So that one little panel rad, basically, electric panel rad, I guess you can call it, is giving you, we're replacing 19 feet of wall space, right? And what is it, 43 inches, I want to say? Yep. So a little over 3 feet. It's a big difference. Make up a lot of space. Furniture layout changes, everything.
I've been really kind of harping on the lower temperature, high efficiencies, and it's just like this. It is a switch. Once you realize that we're a BTU delivery, right? That's what our goal is. The comfort comes from the BTUs that we deliver. And if we have enough of surface area, then we can start lowering water temperatures. So here are these pieces of appliances, like we just showed you here. It gives you low water temperature outputs that are like performing crazy amounts of delivery. And we kind of went one day and we said, well, how many feet of baseboard is that? And it was like astronomical BTU compared to, I think it was even 180.
Right.
So taking high temperature, traditional fin tube, and then going this lower kind of temperature approach. And it's like, we just have to understand we are delivering BTUs, both on heating and cooling. So you can overcome the loss or the gain, well, then you're keeping people comfortable, and that's the business we're in.
So it's the goal, right? So
that is the goal.
Looking at the diagram, this is again just kind of getting you guys to be a little creative and think outside the box. It's different applications. You start thinking of all these different places you would like to put air and water. It's just the diagram here. Some panel rads off a radiant manifold. They will have their little actuators at the panel rads themselves, constant circulation, you gotta say, right? So, so that's an option there. We're looking at maybe taking that radiant heat, right? And then we got a dehumidifier in the system too. So we're doing heating and cooling with one single tank. When there's a call for heating, it's going to maintain the heating side, on a buffer tank, and then on a cooling side, vice versa. So that's kind of what this is showing here, which is cool. And it is also, if you pay attention to the piping of the buffer tank, this is a three pipe setup. So again, there's some benefits there where now, if I do a 3 pipe, I'm getting the hottest water out of the tank, but I could potentially be getting, if the heat pumps are on, the hottest water coming directly out of the heat pump, and then getting, up to that radiant floor. So, there's some different ways of piping it, and, how many pipes versus how many, 3 pipe versus 4 pipe. So, I want to say there's not a wrong way to do it, but there is different methods and stuff like that that'll help, maybe boost the performance of your system. So.
And I know you said it earlier, but just be aware, if you're not that refrigerant savvy kind of, company in that regards, water's been your medium. These are sealed units in that respect. So you really are just kind of resorting back to what you've been doing, It's okay. Know what my loads are, what this produces. I'm doing pumping and piping, sizing circulators, sizing my delivery of, what size PEX or pipe or steel.
Yep.
I'm sorry, copper rather, okay, or even brass. So I wanted to bring that to a point earlier. We're talking about strainers and all. And I did a project. It was out on the East End. It was under a house getting on the beach. And I didn't notice, I didn't pick it up at the time, but they did pipe the outdoor equipment with steel.
So even though we're a closed loop system and oxygen in its play, I was even concerned about the air. It's all salt air, so regardless, it doesn't really matter. But you know, the less ferrous material, right? We like to have PEX is great, sized properly, copper's good, and even brass. So like we call it near boiler piping around what we do in the basement sometimes, or just around our boilers. Well, here's no different. So just be aware of the maybe pathways, the water pathways that we have in our heat exchangers, indoor and outdoor, stuff like that. So,
Right.
You know, might be a little more cost, but I think the longevity and service of
Just
the
gonna
equipment.
say, that's what I was gonna bring up, is like the maintenance side. I mean, I know there's always one person that's asking about maintenance, so I don't know if that popped up yet. So I'm maybe beating to the punch this time, but
Go.
you know, maintenance wise, you know, you think about a hydronic system and now you just removed a fossil fuel source possibly. You know, you're not there anymore servicing the boiler, you know, you're not there to clean anything, you know, air and water heat pump standalone, you know, doing primary heating, you're checking some, you know, heat exchangers, you know, you're putting the system on, you're making sure everything operates, you know, you're making sure the insulation on the pipe is still there if you're talking chilled water application, you know, those are your, you know, and then the most important one is the water quality, right? If we're putting in glycol into that system, we want to monitor, you know, the level as well as the pH of the system, right? So it's not going to last forever.
Not gonna last forever.
So it can break down, and then if you do have materials like you were just saying, then it can really make it, you know, a mess. So, you know, just that's your maintenance really, is water quality, making sure your heat exchangers are clear and the system's operating properly, you know. That's really it. You know, so it's not much to it. This next one I have on the screen, this kind of layout here is pretty cool because the way I did the slide, you know, kind of delaying the actual application. Pumping and piping is the same no matter what we're putting it in, right? We have our, call it our heat pump side, our outdoor side. You know, in this application, you can see our buffer tanks right here. There was a take-out buffer tank. Here's my outdoor units. I got 4 of them in this system. So just some, or if they did it doesn't look like a reverse return.
No.
So they staged these outdoor units. We go through, so there's my hydraulic separator, and then here's my system side. So in this box here, there's 4 air handlers, so it's 4 high velocity units. They put circuit setters on each air handler so that the one circulator over here, right, when that thing's on, it's going to provide the right amount of GPM through each air handler, right? So we get the BTUs. So this isn't a, you know, if you think about maybe a high residential home, you know, where we have multiple outdoor units satisfying the buffer tank, and then we have all these zoned air handlers or something, or radiant heat, you know, anything. There can be really anything there. So
actually, the outdoors are reverse return. If you look at the way the
yeah, that's what I thought it was.
It is. It's balanced.
Yeah.
So they modulate. They bang.
They do, right? So you look at this application and you're like, okay, you know, this could be a home, this could be a building, but this was actually this was a fun application. This was an airplane. You know, so you think about a home and what we do in heating and cooling, you know, don't just, you know, take the blinders, you know, off, and there's different applications out there that, you know, you might not have thought of in the past, but it might make more sense to, you know, go air to water. This project here, they couldn't do a traditional, you know, heat pump system, you know, they didn't want to see condensers, they had to be remote. So we got them on that, well, we got on this project because of that, because now we were just sizing a water pipe, so we were really able to put these things remote. Or actually, if you see in the picture, there's a hatch opening there. I think that was Mr. Jim Bashford from SpacePak with us that day. There's a hatch, and that's where you get access to the 4 outdoor units, and then the air handlers are in the belly of the plane. So this was just a cool little application, but it expanded that, you know, creativity, you know, of what we could do, you know, with our systems. It's not just homes, you know. Here was another, you know, coming out of the certification, you know, classes. This PowerPoint. You know, this is another cool picture of some outdoor units. These are not inverters, but being able to come on a roof, maybe like the one on the right there, I believe that was a church that originally had a 25-ton, you know, package unit on the roof. You know, when you had a call for heating or cooling, that thing only knew to really run at one capacity, you know, where now we have a storage in the building, and we might only have 1 air handler that needs to, or I'm sorry, outdoor heat pump that comes on, right? We might have 2. So now you think about the turn down ratio from going from a 25-ton system that always kicked on to now having 5 5-ton units, right? So I can modulate down to whatever the lowest modulation of one single outdoor unit, right? But then I can bring it all the way up. In this case, this was an inverter, so I'll stick with that. You got 5 banks of 5 tons. You need 5 tons. There's not many people in the building. That's all we're going to deliver you to maintain that buffer tank. We have more people and we're drawing temperature out of that battery or that buffer tank. More outdoor units are going to get fired up, right? So we don't need the full capacity every single time.
No.
By banking these units, it gives us a lot of different opportunities. Here's an above view of one, maybe replacing a cooling tower, who knows, a bunch of large, rooftop units. We can really have some fun with this stuff and get some real good efficiency and redundancy out of the system, not having to worry about a building go down, if you had multiple outdoors go down, stuff like that.
Variable load, variable delivery.
Yeah, this was a school, I believe, that had massive storage in the ground, where they were able to produce it during the day where it was only in the peak times.
Right.
And now all that battery storage, and I think the real story, I don't know if it was this one, I believe it was, they actually had a really bad snowstorm, I believe, and the units were out with no, it wasn't even power.
Oh, no.
The units were still running, and at the lowest turn down and all the energy that they were sucking out of that buffer tank in the ground,
Mm-hmm.
they were just able to maintain enough heat, where the building wouldn't freeze, and
Gotcha.
we're talking negative temperatures, from what I remember. I got to give more details on that, but that was a pretty cool story. So cool application pictures. This is the one I said, 900 gallons of storage, right? This was a pretty cool story, I'm not going to go fully into it, but, this man had a lot of different options as far as getting energy, he had geothermal on his project, he had, I believe, solar, there were a couple different things there.
You're stocking some wood there too.
Yeah,
On
right.
the left-hand side of that
Yeah,
photo.
look at that. Yep, left edge. So this guy was, storing 900 gallons of BTUs, basically, is what it was. So depending on the zones that are calling, whether they're really small zones or whatever it is, they're just feeding off of those 900 gallons,
Right.
So if we deplete it enough, yeah, eventually it's going to turn on an outdoor unit. It needs to be made up, but, here we got to look at maybe dollars and cents and utility rates and see when it makes sense, So that was definitely a cool little one there. This one's, again, we talked about insulation. So you think these are 2 perfect pictures here. One, with a fiberglass insulation, that hard shell. Looks like the other one's maybe a foam. But doesn't matter where that pipe's going or where you're thinking somebody's not going to see it. If it's metallic, it needs to be insulated. Handles, valves, even around the circulator bodies, so stuff like that, they all need to have insulation on them. So there is no exposure to that humid air on there. So you're not rusting out stuff either. So we've seen that in the past. Anything coming up you want to? It's coming up technical as far as piping and insulation. I'm kind of wrapping up here. Keep the questions going, guys. We're going to hang on here a few minutes, as you guys as we're winding down, but a lot of good questions. Anything you want to bring forward, or?
No, I mean, I'm kind of doing some due diligence behind, but it's just a question about different sources to use as our piping. I don't have all the answers. Certainly have some links here that I'll take a look at, but one of the things I was just typing in here about SpacePak.com, if you haven't gone, try and get there, and see what they have as far as resources or options for training. They do have, I think there's a section for the waterworks. Is that on there? Is that something that they have?
Yeah,
out in the open?
Waterworks is on the website.
So they actually partnered up with John Siegenthaler, and he does a whole lot of research himself, or emphasis on air to water. So they have a couple different options or editions of this, and it's really kind of cool to have this resource too. So I have 3 here: air to water heat pump solutions, air to water heat pumps plus boilers, and small scale hydronic cooling. So some of the pitfalls, the highs and lows, and things to be aware of. It's a good reference document. So take a look at that.
Yeah, if you guys are familiar with John Siegenthaler, he kind of assists with a lot of these publications, But yeah, it's cool. It comes in a nice binder with the application guide and all the current versions. So, and it's free, which is cool. Good questions coming through. That's a good question, Jeff. I'm not sure. Non-ferrous extension tank. It's.
Well, I know the domestic one is stainless steel tapping. I don't know what the rest of the tank is made out of. Is it all?
I believe it's
steel.
Probably steel with just the MPT stainless steel.
Correct. Yeah.
Which, why would they do that? But okay.
Yeah. So this is a service that SpacePak offers that I highly recommend you take the information, the email here. It is on the form itself, but we did put it in the handout section, so that's something you want to take with you. If you have a project, even if something you will just want to entertain for your own knowledge and understanding on how things work, these guys are great. You know, that form basically asks questions that you would, you know, all the information you would need to put a load calculation together, manual J. You know, SpacePak will do that. I'm working with an architect and a building owner right now in Montauk, where they're gonna, you know, we're looking at some plans. They already went to SpacePak before they spoke to me and got the whole manual J done. So it's one of those services where you want a lot of information, you have to give a lot of information, if that makes sense. You want to fill out that form as thorough as possible. The more details, then that's the more detailed you're going to get a layout back, you know. And when I say layout, it's a layout assistance. It kind of gives you an idea on where things need to be, you know, placed, or based on CFMs or BTUs. We need to go on site and take that design now that comes back and just go see if it's reality, right? Can we run out pipes certain distances? Are we going to get the right BTUs? Might have to add additional pipes to it, and then from there, you get a basic layout as far as a material list, something to go by, and then we can make our additions to that as well. So these guys, headed by Eric Rainey up there at SpacePak, awesome group of guys. Turnaround is so fast. I've never seen a service, you know, quicker. You know, these guys, I've literally sent them, you know, manual J information, you know, layout, stuff like that, some design ideas, sent it up on a Friday and got an email back Monday, you know, mid-morning, you know. So, you know, depending on the workload and how many people send them in, obviously it slows it down a little bit, but nothing more than a 24 to 48 hour turnaround for these guys. It's been awesome. So grab the form, it's in the handouts.
Take a look at Stanley's question in respect to, you know, just his initial exposure, and usually wants to get a little bit more hands-on or seeing before he dives in, I guess. That's what I was reading there.
Yeah, well, the best thing to do is get to a certification class where, you know, we kind of get more time, you know, a couple more hours to talk about this stuff. So you'll learn a lot more there. Training, that's what it is.
Yeah,
you know?
Kenneth, as far as SpacePak, they are just the high velocity aspect, no traditional, and they don't do DX condensers.
Right.
So they are just the delivery side, and you marry it with your line set and your condenser of choice. You could be heat pump as well. So we are heat pump ready with our DX coils. So.
Yeah, and Stanley, if you're looking for more information, training, stuff like that, we record all of these webinars. So we probably have 3 or 4 different air to water, you know, very similar. We try to keep the same topic and just update it, and, you know, the conversations change throughout them, but we record all these webinars. We place them on the website that you see here. This is walesdarby.com. You go into the topic training and events. There is a video section, so you'll have all the webinars that we've recorded in the past. So a lot of extra education there. You also go have the calendar, which kind of gives you, you know, the current events, what we got going on as far as webinars. Hopefully some in-house training coming up soon, so we'll have those on there, hopefully. But, you know, here's a list. You can see next, we'll take a little break with Thanksgiving coming up and the holidays. We'll be back on the 29th, where you're going to see Anthony and I will be here again, I believe, for low temperature hydronics. So, you know, have a little bit more deeper conversation of, you know, low temperature and get a better understanding and hopefully a better comfort level than what you've had in the past. So you have that information there. You can register for that webinar. We had a good turnout last time. Every time we do that one, it seems to be a really good one. So I'm looking forward to it. So as we kind of wind down here, any more questions you want to throw them out there in the chat? I'm going to hang out for 2 seconds, see what else pops in here. Again, we appreciate you guys for your time, jumping on
Always.
just about a little bit, about an hour and a half we're at right now. So good conversation. The thing's been going nonstop. So.
Thank you, Jeff, as always, for supporting and being around.
Yeah.
Good information shared always. Thank you for that.
Yeah, so if you guys have any questions, anything that we missed, you know, or you didn't hear us talk about, you know, feel free to throw it up there.
You know, if you don't do heat loss, I always put it out here. If you're not someone who does a heat loss, or if you have a home and you live with equipment and boilers, and it's interesting to learn for yourself, apply it, and kind of compare what your home's equipment is versus what the actual loads of the home is needed. And this bigger is better approach really kind of sits every day. It's just common practice, and we need to kind of see the difference, kind of start practicing and reversing that and realize, again, it's not about temperature, it's not about bigger is better.
Yep.
Short cycling isn't a good thing ever. So, lowering water temperatures does achieve a lot of high efficiencies. So again, the lower water temperature isn't a bad thing.
Nope. Good. I don't see anything else coming in, so.
I was looking up on FlexCon. That's a brand of FlexCon or expansion tank. So I don't know why I'm struggling with my cell phone to see about their domestic expansion tank. I know it's stainless steel at the connection point.
Yeah.
If I find out, Jeff, I'll try and forward something your way.
Yep.
Good question. Again,
All right.
pertaining to having all things non-ferrous in our systems, better off for the system.
Oh, absolutely. All right.
All right, guys. Thank you again.
Yep. Thanks, Jeff. Appreciate it. All right. With that,
Enjoy the
guys,
rest of your day.
we're gonna say have a good day.